Welcome to the Unit 7 Constructed Response Help video. We're going to go through a similar question to what you're going to see on your Unit 7 test. For part 2, just a quick refresher, in this unit we're looking at the difference between arithmetic sequences and geometric sequences. Remember that your arithmetic sequence would be a linear function where you have a common difference or a slope. That's when you subtract your terms from one another, and then your exponential is geometric, and that's when you have a common ratio. So when you divide your terms, you end up with the same result looking at your terms. So that's what we're. So the question is, you invest money for retirement. The table below details how much money M you have at the beginning of each year, T. The rate of return will stay the same. So here I have my numbers of years and then my amount in the account after each of those years. So these are, you can think about the years as terms. I want to know what type of sequence that can be used to model the amount of money in our retirement account. So if you'll remember, there are two types that we just talked about. You have your arithmetic sequence. This is when we have that common difference, my D. So D is a sub 2 minus a sub 1. So if I go over here, remember that each of these years you can treat as terms because this is a sequence. So I'm going to see if these two terms, when I subtract them, are the same, if I get the same difference throughout my values. So when I start this and I subtract these two from one another, I end up with 360. And then if I were to continue and I try the next two terms in the list to see if that difference is the same, when I do that, I discover that they're not the same because this answer is 432. So this is not an arithmetic sequence. So now I'm going to go and look to see or prove really why it's geometric. So when I have a geometric sequence, we have a common ratio. So when I divide, I should get the same answers every time after I divide. So if I take 2160 and I divide by 1800, when I put that in my calculator, I get 1.2. And then when I do that again for the next two, 2592 divided by 2160, I end up with 1.2 again. And then if I go one more step and try that last, I end up with 1.2, which is what should happen. Since it's geometric, we want it to be to have the same ratio throughout. So when you're explaining your answer, if you show your work like this, that's totally fine. You can say it's geometric. You could write a sentence if you'd rather do that. But this showing your work like this is totally sufficient for explaining your answer. Now in part B, it says to write the recursive formula to express M of T or M sub T, the amount of money in the retirement account after T years, in terms of the amount in the account the previous year, M sub T minus 1. Now, when they talk about the previous year, that's what the recursive rule is. You need to know the value of the year prior to find the value of the next year. That's what the recursive formula gives us. So no matter what we're finding, you have to give your first term in the sequence and you have to find your R, your common ratio. So my first term is just whatever the first term is that's listed, that's a sub 1. My common ratio we already found, it's 1.2. So now I'm just going to go ahead and plug in my recursive formula. I'm going to rewrite it over here and then we'll fill in the pieces. So a sub n equals r times a sub n minus 1. Notice though that in this problem it tells me to use m sub t. So I'm going to change the a sub n into m sub t. My ratio is 1.2. I'm just plugging that in. Instead of using a, we're using m. Instead of using n, we're using t. So I'm just changing the notation. But this is my recursive rule. This is what I need. I need that first term and I need the rule. So all this does is if I want to know the next term in the sequence, I take the term I know, so the 1800, and if I multiply it by 1.2, that's going to give me the next term. And then if I were to take this term, 2160, and multiply it by the next term, or multiply it by 1.2, I'm going to get 2592. And again, if I take that amount and I multiply it by 1.2, that's going to give me the next answer, so on and so forth. That's the recursive rule. And the next slide, we're going to write the explicit rule. We need the same starting information that we used in our recursive rule. So my pen here, a sub n, nope, a sub 1 was 1800. My r is 1.2. Nothing is changing. And now I'm just using a different formula. A sub n equals a sub 1 times r to the n minus 1. Again, I want to use m sub t instead because I'm using the variables that were given to me in this problem. A sub 1 is the 1800, so that's what I'm going to plug in here. I'm going to multiply that by my common ratio of 1.2, and instead of using n, that's my t, so it'll be t minus 1. This is my explicit rule. That's it. Now, next example, I'm going to use that same rule that I just wrote. I'm going to rewrite it here, and I'm going to use it to help me find an answer. It says use your explicit rule or explicit formula from part C to find the amount in the retirement account after 15 years. So I want to know when T is 15, how much money is in my account? What is my value of M? Show all your work. So all I need to do is plug in 15 for T and then solve. So when I plug this in my calculator, I end up with $23,110.53. But it says to round your answer to the nearest dollar. So since I have 0.53, that would round up. So that would turn into $23,111. That's my answer. Then in part E, I want to convert that into euros. So I'm going to take that answer, which was in dollars. Okay, if I put that over 1, I can now multiply by my conversion rate. Since I have dollars in the numerator, I'm going to put dollars in the denominator because I want them to cancel. Okay, so those go, oops, those are going to go away. I'm going to have €1 in the numerator. So when you are multiplying fractions, you multiply straight across. So 23,111 times 1 doesn't change the value. Same with the denominator, I'm just multiplying by 1. So really all I'm doing is dividing those two terms. Oops. So 23,111 divided by 1.14, and I end up with 20,272.81 euros. Now, it doesn't tell me how to round. If I do it the same way we did last time, I would round up to the next one. And that's my answer. You will follow the same type of procedure to go through your question for the Unit 7 constructed response. If you have any other additional questions, you can reach out to me in an email.